Well, don't want to say like little kids get it, like. Okay, so we were doing midpoint yesterday. So we did left, right, we started coming up with midpoint, right? Alright, so our width was 1/4. So the midpoint of that would be 1/8, and then so on. Okay, so I have 1/4. 1/8 squared would be 1/16 plus, is it 16? 64. Amateur hour. 1/64. 9/64. Because our function is x squared, right? So if I plug in 1/8 into x squared, I get 1/64. So then you get 25/64 and 49/64. We go with that? So what's that? That's 10. 10 and 25 is 35. What is it? 84. Okay. So you have 1/4. Times 84/64. And what would that be? What is it? Oh, you simplified it. Is that what you're saying? One. Okay. All right. How is that 15/64, 31/64, 21/64? All right. So we're kind of like all over the place with our answers. Okay. So the last method is your trapezoid method. All right. So what we're going to do now is you're still going to use a width of 1/4, right? And now I'm going to break up the region into 4 trapezoids. All right. Now, when we are finding the area of a trapezoid, it's 1/2 the sum of your bases times the height. Okay. Now what we're going to do is we're going to use the height to be delta x. Okay. And then the side lengths are going to be your 2 bases. All right. So this would be like B1, and this would be B2, and then this will be the height. Just delta x. All right. All right, so if I'm going from 0 to 1/4, right? I forget how to draw these. Goes to there. 1. Right. But I mean, it could be like a trapezoid, so the one base doesn't have, it has a height of 0, right? We could use that. Right, but I think because this point here is right at 0, 0, that's why you're not going to get like, you're not going to get like a perfect trapezoid. It'll be, yeah, it'll be straight. So you should, mine's probably more curved. Yeah, so you should go from like right here and then draw a straight line to like right there. We're at 0.25. So then my next one would be from 0.25 to 0.5. Right, so I'm going to draw a straight line kind of like that. I'm sorry? Yeah. So 0.5 to 0.75 would be my next one. Right, so now it's looking better. And then the last one would be from 0.75 to 1. So yeah, this one's looking pretty good. Okay, so what we're going to do now is, again, we got to figure out the area for each of these trapezoids, right? So area approximated by trapezoid. Okay, so the formula always calls for 1/2 times the sum of the two bases times the height, or the width of the trapezoid, right? So we know that it's always going to be 1/2, right, times what is our height in this case? 1/4, right? Come on. All right, now I have to do the sum of my two bases, right? So my first base would be f of 0, and then my second base would be f of 0.25, or f of 1/4. So f of 0 plus f of 1/4. All right, so that would be the area for the first one. So we're like, you're taking like a trapezoid, it's almost like on its side now, right? So this technically is it's probably easier if you look at the other one. Like, this is the height of your trapezoid, right? And then this is your like top base, this is the bottom here, right? So we're using the height to also be our delta x, which is also like the width of the other rib. This would be whatever f of 1/4 is. That's how long that one is. Right. 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 So then the next one, again, I have 1/2 because that's part of the formula, times 1/4, which is my height, and then the sum of my two bases would be what? F of 1/4 plus f of 1/2. Good. Alright, so that's the second one. Now the third one would be what? 1/2 times 1/4. The sum of my two bases would be what now? f of 1/2 and 3/4, right? Okay. And then the last one would be plus 1/2 times 1/4. And then the sum of my two bases would be f of 3/4 plus f of 1. Okay, we go with that? So this would be the first one, second one, third one, fourth one. All right, that's the height of each trapezoid, right? So we're taking an area with a length of 1, and we're breaking up into 4 equal trapezoids. So each of those trapezoids is going to have a width or a height of 1/4, right? Now, that's really long and tedious and disgusting, right? Okay, so we need to figure out an easier way to come up with that. Okay, so if you're using the trapezoid method, right, you're always going to be multiplying everything by 1/2, right? That's part of the formula, right? So what I can do is I can put that out front. So the area right? Now, what else did I multiply everything by? 1/4, right? And that's also my height. So anytime you are doing a trapezoid method where everything is the same, right? They all have the same height, you can take 1/2 and then you can put the height right out front as well. Right? And then this would be delta x. Okay. All right, now, looking at what we have left, right? How many times does f of 0 appear? Once, okay. How many times does f of 1/4 appear? F of 1/2. Twice. 3/4. And, okay, so whenever you're doing the trapezoid rule, right, and you break it up evenly, right, you're always going to have your endpoints are only going to appear once, and then everything in between appears twice, right? That's going to be true for regardless of whatever curve we have, width, whatever, right? Whenever you're doing the trapezoid, you're always going to have it's 1 times the first endpoint, 1 times the last endpoint, and then it's 2 times everything in between. So how I would write that would be f of 0 plus 2 times f of 1/4 plus 2 times f of 1/2 plus 2 times f of 3/4 and 1 times my last endpoint. All right, so that right there, you guys really need to kind of commit to memory. All right. That's your trapezoid method, right? That appears a lot as test questions. So again, it's always 1/2 times the height, or delta x, and then it's 1 time the first and the last endpoint, and then 2 times everything in between. Does that make sense? I'm not like pulling anything out of thin air. All right, so let's simplify it. So we got 1/8. F of 0 I know is 0. F of 1/4 is 1/8 times 2 is 1/4. Oh, you're right. I'm sorry. Because I multiplied instead of squaring it. So 1/4, right? So 1/4 squared is 1/16 times 2 would be 1/8. You get 2/16, right? Right? Does that make sense? Okay, and then when you square 1/2, you get 1/4. You multiply that by 2, you get 1/2. If you square 3/4, you get 9/16. Plus times 2 would be 8/16. 18/, yeah, that's what I meant. And then f of 1 is just 1. Okay, so I got 1/8, and all right. So this is 16 is probably the easiest one to use, right? So this is 16 plus 18 would be 34. What is it? 28/16. So then 28 plus 16 is 44. Okay, so I got that would be 2. That would be 11. 11/32. Okay. All right, so those are the big 4 methods. This is like numeric integration, definite integrals. That's not exact, but it's very, very close. Yeah. Usually, yeah. So it all depends again on what type of function you have and what the curve is, right? So if this curve is what, concave up or down? Concave up, right? So anytime you have a curve that is concave up, your left approximation is going to be less than what it is, and then your right approximation is going to be bigger than what it is. Now, if it's concave down, it's the opposite. Left would give you more, right would give you less. So again, it all depends on how the curve looks. All right, so let's figure out what it is. Yes? Did you do that? Oh, no, if you average the left and the right, you should be able to get the trapezoid 1. So if you do 15/64 plus 31/64, and then divide that by 2, you should get 11/32. All right, so if you do area, so if you take the average of the 2 of those, they should give you close to what that one is. Say again. That's what happens when you don't pay attention to your multiplication. Multiplied wrong. So that's 16. So that's 10. That's 10. That's 14. So what's that? That's 30. You did that wrong too. So 10, 14. No. So that's 14 over 64. All right, that's better. That's good. All right, so Kel, if you do 14 over 64 plus 30 over 64, and then divide that by 2, what do you get? Yeah. So again, if you had like a test question and you already had the left and the right, and they were asking you for the trapezoid, you might, instead of having to do the whole thing out, you might be able to take the average of it. It might be able to save you some time. All right, so let's see what the calculator gives us. All right, so to come up with the derivative on the calculator, what was our button sequence? Math 8, right? So if you're going to come up with an integral, it's Math 9. So it's just one more. Yeah. All right, so how should we set this up? So if you have the new way, right? So we were looking at the region going from 0 to 1, right? So my lower bound was 0, my upper bound is 1. And then you're going to type in x squared and then dx. All right? If you have the old, it is fn int. You're going to type in your function. So in this case, it would be x squared, comma x. So this is saying take the integral of x squared with respect to x, and then I'm going to look at it from 0 to 1. Right. Yeah, your lower bound goes first, your upper bound goes second. So if you have the new one, it's pretty self-explanatory. But so you hit the math button, then you hit number 9. And then I'm going to type x squared, comma x, comma 0, comma 1. Okay, so the other ones we got was what? 11 over 32. So we were pretty close. Yeah, that's the exact, right? So what this is saying is if you took that same region that we were just working with, right, and we broke it up into like an infinite amount of little tiny rectangles, right, and then you added all those areas up, that's what your area would give you. Okay, it would be 1/3. Right, so instead of actually having to do that whole process a million times, we can just do the integral. So 0 to 1 of x squared dx is equal to 1/3. So all your methods, again, they're not exact, but they're very, very close. All right, so finding the area approximation using left endpoints gave us an over approximation. Using the right endpoints gave us an under, yada, yada, yada. So again, what we just did was we came up with that, right? This is your definite integral, right? And doing the whole finding the area process, that is what's called Riemann sums, named after the guy who invented them, Riemann. Right? So Riemann sums will give you your definite integral. All right. Okay, so what I'm going to let you guys do for the next 10 minutes, see if you can come up with the next one. So we're using an integral from 1 to 9 of the square root of x using 3 subintervals. No. So you're going to try and come up with the left, the right, and the trapezoid. I'm going to change that. Make that from 1 to 9, make that 4 subintervals. It'll be easier if it's 4. Because if it's 3, right, to come up with, how would you come up with delta x? So that's the width of each of your rectangles. You would take your upper bound minus your lower bound, and then divide by the number of intervals that they're asking for. So instead of it being 8 over 3, it'll be just 2. All of these are the left Riemann sum, right Riemann sum, midpoint. Those are rectangles, and then the last one would be trapezoid. All right, so delta x would be 9 minus 1 over 4, which would give me 2. All right, so see if you can figure it out. I would maybe draw the graph if you have a hard time kind of visualizing it, but you don't have to. You can kind of just do the math out.